Alright, so with 17, we are still performing the indicated operation and expressing in lowest terms. And you'll recall from previous videos, now we're into the questions where we are having to build our common denominator. No longer are they giving us a common denominator. And so again, because we're dealing with an expression, not an equation. Remember, equations have equal signs, no equal sign anywhere in here. With expressions, I like to stack my two fractions, or if there were three, I would stack the three, and that helps me to keep my information organized while I'm trying to build that common denominator. So I'm going to go ahead and rewrite each of these terms here. So we have 3y squared minus 3y plus 2, and we have plus 7, so that's just a 7 over y squared minus 1. Alright, and we know that we're trying to build a common denominator. So let's see. The first step is to factor each of the denominators. So trinomial here, no GCF, coefficient is 1. So this is going to factor into two binomials, y and y. And we're looking for factors of 2 that add to negative 3. Well, I think we're going to have negative 1, negative 2. And here in this denominator, y squared minus 1, that hopefully you recognize as being the difference of perfect squares. So we have y plus 2, oops, excuse me, y plus 1, y minus 1. And so now that we've fully factored both denominators, we can clearly identify what terms we are working with, what factors we're working with. Because remember, the common denominator that we're building has to have one of each thing that is unique, one of each factor that's unique. So y minus 1, y minus 2, y minus 1, y minus 2, all right. Y plus 1. Y plus 1 was not in our first denominator, so since y plus 1 is unique, it has to be part of the common denominator. So y plus 1. And the second factor here, y minus 1, was already included from this denominator, so we don't have to rewrite it. So now it looks like we've included one of each thing that's unique. So here is our common denominator. So I'm going to go ahead and rewrite that common denominator down here, y plus 1. And now we're going to figure out what it is that we need to multiply by. Because we have y minus 1, y minus 2, y minus 1, y minus 2, well, that means we're missing the factor y plus 1 from here, doesn't it? Well, how do we incorporate that y plus 1 into the original denominator? Well, to get from here to here, meaning to get from 2 factors to 3 factors, we had to multiply by the missing factor. So we are technically multiplying by y plus 1, which gives us this common denominator. And whatever we multiply the denominator by, we have to multiply the numerator by, right? Whatever we do to the bottom, we have to do to the top. So y plus 1. And now we get to perform some operation, some multiplication. 3 times y, well, that gives us 3y. And 3 times positive 1, well, that just gives us 3, doesn't it? All right, well, now let's take a look and see what we have down here. Y plus 1, y plus 1, y minus 1, y minus 1. So which factor are we missing from the original denominator? Well, we're missing the y minus 2. So that means that in order to get from the original denominator, y plus 1, y minus 1, to the common denominator, y minus 1, y plus 1, y minus 2, we had to multiply by y minus 2. And again, whatever we do to the bottom, we have to do to the top. So y minus 2. Let's perform some multiplication. So 7 times y gives us 7y. 7 times negative 2, that gives us negative 14. And now that we've built our common denominator, this common denominator simply moves over. So y minus 1, y minus 2, y plus 1, and now that we've established that common denominator, it means we can combine the numerators. So 3y plus 3, 3y plus 3, plus 7y, right? Because this is a positive 7y. So plus 7y minus 14. And let's go ahead and combine some like terms here. So 3y plus 7y, well, that gives us 10y. And 3 minus 14, well, that's going to give us a negative 11 over that common denominator. So y minus 1, y minus 2, and y plus 1. And again, if you could factor your numerator to cancel with something here in the denominator, go ahead. But in this case, we can't factor this any farther, and so we have 10y minus 11 over the factors y minus 1, y minus 2, y plus 1. And it's important to note that you can write your factors in any order. So you could have had y minus 2, y minus 1, y plus 1. It doesn't matter, again, what order the parentheses are in. What matters is what's inside the parentheses, but the order of the parentheses does not matter. All right, there was number 17. Let's take a look at number 18.